So we're going to continue page 245. Now we're going to save the state park symbology to a layer file. So now we're going to do is state parks, and we're going to save as a layer file. Hit save. So now the historical, shipwreck, and state parks layer files can now be added to any map because their reference, their source, feature class, shipwreck, and state parks. The feature classes must also be accessible on disk or across a network. If you send a layer file to someone else, you must also send the data source that it references. Now we are going to do one more step. So shallower. Can you figure it out how to symbolize the bathymetry layer using gradual colors based on depth measurement in meters? Shallow water should be light blue and deeper water dark blue. Your results will be resemble the graphic. So if you succeed, you are ahead of the game. So, wow, let's try it. First, we have to go to bathymetry, and we're going to go properties. Nope, sorry. Let's look at what the data is. So shape and depth. So, we have a depth, and we can rank sort it. So now the shallow is 3, and then we can scroll down until 100. Wow. Okay, now we're going to do a gradual symbol map. Value, we're going to do depth. Oh, in meter. And then we're going to do classification to manual. Okay, now it's horrible. Let me look at the data again, and we could just get statistics. Depth in meters. Mean is 16, sum is this much, maximum is 54,000, minimum is 0.09. So we can do from 0.05 to 5,500. Okay. Make sure it's meter, depth is meter, and then 5500, and the minimum is 0.05 here. Oh. 0.05, and medium we can make it other, we see 3, and we can do it 5 and 16. So we know the majorities are we can just do natural breaks. mean is 17. Mean is 17. Mean is 17. Okay, now we're going to move to page 247. We're going to save our work and we go to the next one, exercise 07D. Firstly, we can see everything here in our bathymetry. Yay, we did a good job, but except for classification. They did was to 0.09 to 200, 1,000, 2,005. We did 55,000. So we can go back to change it as well. And we can change the symbology. So that's why our map looks skewer. And we can change it back real quick. Right click on it and then classify. The breaks, the first one is, I forgot. The first one is 200, 1,036, 200, 200, and then 1,000 and 2,000, 36,000, and we can leave the 55. Hit apply, hit OK. And we can refresh our map. There, now it looks better. And cool. It's really beautiful map. And we save it. And we go back to this one. Okay, now we're going to continue that this map contains the familiar Florida layers with which you have been working on. So we have been changed everything for the previous video, and in the table of content, expand the ocean background legend, and we're going to do that, and you are going to see RGB. R is red, G is green, B is blue. So you can see that the ocean background image is a 3-band raster symbolized by a red, green, blue value for each band. Next, you will add elevation and hillshade raster layers to the map. So to do that, we're going back here to look at our data, shadow, and then the DM. Oh, check the wrong one. Okay, now, first, we have the SHDRL raster added in our ArcMap, and now, if prompted, it already builds the pyramids. And now we're going to jack. We already jacked the USGS DEM, and also it builds the pyramids. A pyramid is a reduced resolution raster layer that copies the original data in decreasing levels of resolution to enhance performance. The coarsest level of resolution is used to draw the entire data set quickly. As the display zoom in, the layer with final resolution or drawing speed is maintained because fewer pixels are needed to represent the successively smaller areas. You need to build pyramids only once for a raster dataset. They are stored with the data as a file with the extension RRD. The rest layers are added near the bottom of the table of contents above the ocean background layers. Next, you will rename the rest layers, so we're going to do that. And to do that, remember how to rename our raster data. So we're going to click the ArcGIS26 and we're going to type elevation. And now rename the SHDRL to hillshade. And our map going to look like this. In the table of contents, click the elevation layer and hold down the control key and click hillshade. Both rasters should be highlighted, and we're going to drag below the county layer and above the southeast layer. So now we're going to hold the control and click elevation, and we're going to move right here. And now, so we have the elevation and hillshade, elevation and hillshade. Maybe elevation comes before hillshade. And now, the rest layer are repositioned in the table of contents and are displayed on the map. By default, rasters are drawn in shades of gray. Next, you will choose a different color ramp for the raster layer. For raster layer, we're going to do is we're going to the table of content, double click elevation layer. On the layer property dialog box, we're going to click symbology, elevation property and symbology. Okay, there are four raster display method in the show panel. In the stretch method, the default ArcGIS map makes subtle transition along the selected color ramp but doesn't give you precise information about which data value are associated with which shades of color. In the classified method, color transitions are less subtle, but you can see exactly which value ranges correspond to which shades in the unique value method. So unique value right here. So we're going to play around a little bit. Vector method and unique, classify, stretch, and default is stretched. Okay, we're going to review this in the next video, so these are important, so we're not going to go very quick. We're going to correspondingly to explain it in next video.